Okay, gang, today we have a 19-inch G07 CBO, and this was acquired in the recent monitor haul from Kansas City I got last weekend. And we can see here that the flyback has exploded here with extreme prejudice. Yikes. Kaboom. So, not only that, the fuse here has died as well, or is gone. So the I forget what F902 I think that is F901. F901 is the 1.25 amp fuse right there, also got taken out. So I replaced that fuse by doing my method of sanding the sides of the fuse itself to make it nice and dull so I can solder a leg onto each side. So I sanded the sides of the fuse, soldered a leg onto the sides, and put a new fuse in. So F902 has been replaced. The voltage regulator checks good. The easiest way to test that is to go to ohms here, and if your B plus resistor reads 220 ohms, which we have 219, 220, your voltage regulator is good. If this reads shorted, your voltage regulator is shorted. It reads zero, I should say. If it reads zero, it's shorted. So that's the easiest way to test voltage regulator. The more abstract way is to put your negative lead, meter in diode mode, negative lead on one of the screw heads, and touch each leg. You should have a 0.5 voltage drop to one leg. The other leg should be 0.180, which is your reading through the B plus resistor. So that's good. HOT, same thing. You put your negative lead in one of the screw heads, like so, and then you touch each one of the two legs. You should get a 0.5 voltage drop, 0.498, and another 0.5 voltage drop, 0.47, so HOT is fine. So miraculously, the HOT and voltage regulator survived this flyback exploding. It likely sent all the voltage to the frame, which is the ground, and took out F902, was it? F901, I did it backwards again, so F901. So that appears, the only issue appears to be with F901 being taken out by the flyback. So obviously the flyback is the main issue, but the fuse got taken out. That's the only thing that is bad that would keep the light bulb test from working, is the fuse being open. And of course the HOT is removed from the circuit to do this. So in order to do the light bulb test on the G07, the easiest way here is we can simply desolder the wires off of the HOT. You can see that this wire here is removed from the HOT. This one goes to that leg. Then we have another wire here. Where did it go? This wire here is off, the yellow wire. The yellow wire goes to the other leg. So you take off the yellow wire, the orange wire with the capacitor. So now our HOT is completely unsoldered from the chassis. And now we can simply hook up our light bulb to simulate a CRT, and it should work. So we can take our negative lead, attach it to the frame here, like so, with our alligator clip. The positive can go to the regulated side of the B plus resistor off the voltage regulator, and we'll attach that, like so. We'll go to volts DC. Now we need to simulate a CRT being hooked up. We can do that with our light bulb, 60 watt incandescent light bulb. We'll hook one leg to ground, other leg to the regulated side of the B plus resistor, and the light bulb should light up, and we should get 108 volts. B plus on the G07, no, 120, is it 120? I don't remember. It's been so long. 108 is the Sanyos. I probably should have done research first. It's been so long since I've looked it up. Let's look here real quick. So the 108 is the Sanyo 20EZ. The G07 I thought was supposed to be 120. How come I'm not seeing it? So give me a moment, hang on. This is the amateur channel. Slow down here. 120, I'm right. Okay, so all right, so now we're all hooked up. You know what to do. You know what has to happen. We have to have a functional voltage regulator and a functional fuse. Both the AC input fuse and the F901. I think it's F902 and F901. Both the fuses got to be good, and the voltage regulator has to be good. And assuming everything else on the chassis and the power supply has to be good as well. But that's the main thing. So we got our power hooked up here from our isolation transformer. So when I flip the switch on, we should get 120 volts on the B+, and our light bulb should light up. So here we go. 1, 2, 3. Okay, light bulb lights up, but we're only at 108.4. So we need to adjust our B+ pot right here, this guy right there, to 120. Right there. 120.2. Fantastic. So even though our flyback has exploded, the only thing that appears to be a casualty as far as the power supply was F901 got taken out. So we now have a functional B+ system and a good power supply, and we're at 120 volts on our B+. So hypothetically, I should be able to do a cap kit, replace the flyback, and it should work. Now, a couple of things you want to check also as far as the power goes is we want to make sure that there is a 220 ohm fusible resistor here. This guy right there. This guy right here. You want to make sure that actually is good. Should be 220 ohms. If we go to ohms, we read 216. So good, close enough. That can get taken out as well when F901 goes out. This can also die. Also, I think it's R68 up here. I think it's R68. No, I'm sorry, I'm not even close. FR401. It's been so long since I've worked on a G07, I can't recall. This guy right here, FR401. It's a fusible resistor, just kind of like how this one is. So this guy right there, this ceramic resistor right there, it's fusible resistor 401. We need to check that. It should be 68 ohms. That can get taken out quite often and cause the chassis to have power issues. So we'll check that, and we get 68 ohms. So that's fine. Okay, so yeah, I mean, based off of that, I can cap this, replace the flyback, and it should work. So let's do that and see what we get. I need to reattach the HOT, which is no problem. If we can disconnect power here, and okay, flip this around. Let's inspect the bottom side. Or width. Oh, holy crap. Holy crap. Yeah, I'm glad I looked at this because FR514 is missing. This resistor is missing right here. There's supposed to be a resistor right there. She gone. Oh, hang on, there we go. That resistor's gone, and not only that, this chassis appears to have gotten hit because our width coil is broken, not the coil itself, but the plastic part, and the pad is lifted there, as you can see. And not only that, the board is cracked. Hello! Wow. I didn't even think to look at that. I was just going to hook up the HOT and do the work. I would have obviously found that while doing the cap kit and the reflow, but I didn't notice that till just now. So we're going to have to find an R514, which I got parts chassis to steal that off of. Anything else that I don't see anything else just immediately. But I guess what we'll have to do here is make sure we have continuity across that. If we do, I'll fix these here on camera real quick. Let's get this light bulb out of the way because it's causing me issues. Nothing's ever easy. Hang those back up. You get over there, you. And yeah, it's interesting. I've never seen this type of heatsink on a HOT before. That is odd. Anyway, okay, so I'll find the R514, get that replaced later, but I'll fix these cracks, and then I'll do the cap kit and the reflow and hook the HOT back up and come back on camera and see if this works. But let's go ahead and fix that stupid overhead thing here is loose. There we go. Okay. Let's see if we can fix these. I want to keep that in frame here. All right. So it's time to break out the fiberglass pen. Okay, sorry about that. I had to go looking for my fiberglass pen. Couldn't find it, so all right. Let's get to scraping here. Okay, I think that'll work. Let's get these fiberglass bristles in the trash can before I breathe them in, or they wind up all over the test bench and end up in my hands, which has been known to happen. Okay. I'm going to take a quick picture of this here. All right, now let's make sure we don't bridge these two traces because they're not supposed to be connected. Okay. There you go. How about that? Let's make sure that they're not connected. Actually, you know what? Let's clean it up first here. Okay. Let's make sure they don't have continuity because we do not want them touching each other. And we'll go to continuity mode and touch our leads together. Yeah, I messed it up. All right. So anyway, yeah, let's do this. Oh, those are touching. Oh, wait a minute. They are supposed to be touching. Wait a minute. I'm a numbskull. Look, they both go to the same trace. Here's this main trace, and they branch off and go. I mean, see, it's all one trace. It's all one trace here, and they branch off and go separate places. So what we can do is we can just do one big solder blob if we want to, but I think I'll just leave it like that. I think we'll just leave it the way that it is there. Yeah, it looks better that way. So I'm going to snap another picture here. Okay. Yeah, I don't know. In the picture, those joints don't look very good. I'm going to hit that again. Hit that again. Okay. Let's see here. We'll call that all right. And yeah, I think let's find an R514. I'll get that replaced. I'll get the HOT hooked up. I'll get the cap kit and the new Flyback installed. We'll come back and show it off. And then, yeah, HOT hooked up, I guess, as well. Might want to try that. And then I think we'll just go ahead and test it and see what we get. So fingers crossed that works. But at least we know our power supply is okay. B+ is set properly. So if we have problems, we know. Or if we have problems after we get it all put back together, we'll know at least that that's not the issue. So let me get all that done. I'll come back and it'll be ready for testing. Okay, so here it is all cleaned up, full cap kit, full reflow. There was a whole bunch of oxidized and dull solder joints that were right on the cusp of about to crack or break. There was almost no solder at all, so I reflowed pretty much the entire chassis. We got the fuse changed, the cap kit, the reflow, the new Flyback, a brand new With coil, a brand new 5R14, or I'm sorry, not brand new, a replacement R514 from a donor chassis, and I think that was the right, yeah, R514, as mentioned before, replaced that. Got the HOT hook back up, and I got this black gunk all removed from this diode here that was there before, if you saw that. Yep, all cleaned up. I also kind of, both these pads were lifted on the with coil. We saw before this one was cracked, and I actually talked about how I needed to check it and forgot to check it, but when I changed the coil out, I had to put this big bridge across here because both of them were actually cracked, and this one wasn't even in the circuit. So yeah, it was just, I had to put this nasty looking terrible joint across there. But that's done. We got the cracks fixed and all that. I didn't find anything else that was out of normal or out of whack or abnormal, I should say. So yeah, nothing left now but to try it. I did find on the neck board, these two pots here were completely corroded and falling apart. So if we look at the parts here, yeah, both of those were heavily corroded, and this one was all corroded as well. This one here was so corroded that when I took it apart, or I'm sorry, when I took it out of the chassis, it just completely fell apart. This piece fell off the back, which is the adjustment part of the pot there, and then when I actually unsoldered it and took it out of the board, it just completely fell apart in 5 pieces here. So both these were just unsavable. So I stole some replacements off of a donor chassis, and these are good to go. So no issues there. There was a little corrosion on this wire there, so I cleaned that up with a little bit with the fiberglass pen, and it's fine the way that it is. A little bit dirty, but that's as good as I can clean it without actually removing all the components and scrubbing it. So it's good enough now for testing. Maybe I'll replace it or clean it in the future. So altogether we had this with coil that needed replaced, the broken and corroded pots. We had the fuse that was open, and then we had this flyback that was destroyed. So all told, that's really what was wrong with it so far. And our initial testing shows that our power supply is good. Assuming that everything else is okay, HOT was fine, FR401, and I keep forgetting what that one's called, FR901 and FR401. Those are good. So I didn't check these two diodes. I should probably do that. There's two diodes in here. This one here can be bad, and that one there can be bad to cause it to have issues upon power up. So we'll just go ahead and check those real quick. This one goes this way, and we should get 0.45 voltage drop. Actually, with it being a power diode, I'm not really too worried about it reading 0.290. I think that might be normal. What does this one read? See, that one's 0.45, or 0.47, I should say, 0.5. I always round up to 0.5. This one, I think that's actually a normal reading. I'm not going to really worry too much about that because it's not shorted. That's all I'm really worried about, is it not being shorted. So, yeah, I'm not really too worried about that. So, okay, I think we'll just get a tube and turn it on and cross our fingers. And right now, I'm only worried about it powering up. If it powers up, then that's great. We can proceed from there. If it powers up and has issues, we can proceed from there. But if it powers up and works, then hey, we'll make some adjustments and call it good. So let's grab a tube and turn it on and see what happens. Okay, we're all hooked up. We got our anode, neck, yoke, ground, power, remote. Well, there's no remote. The pots are on the board, I should say. I did decide to hook up video, so we have our test pattern generator here ready to go in case it does work. So we'll turn that on. I also hooked up the meter and set this so we can read our B+. Again, your negative can just go to the frame. The positive goes to right there on the regulated side of the B+ resistor. It should be 120 as our tests indicated before. And put my stuff away here and clean up. Okay, is it going to work? Is it going to even power on? If it is, if it does, are we going to get collapsed or something? I don't know. TPG is on. Okay, let's turn it on and cross our fingers, see what happens here. 1, 2, 3. Okay, it does come on. And what are we going to get here for the video? Anything? Yes, okay, and we have 121, which is close enough to 120. Not going to worry about that 1 volt. But I haven't made any adjustments. This is still how it was from when I got it here. So looks like we got horizontal hold problems. So let's mess with our H freak. That's not good. There we go. Now let's mess with our vertical freak, which is vertical hold, which is over here. And, oh, you know what? I think I'm on medium res. Yes. Okay, hold on. Off. Standard res on. There we go. Okay, let's go back to our H hold. I'm like, wait a minute. How come I don't have the normal screen on here? There we go. It's a miracle. Okay. Well, we got lucky on this, it looks like. Let's adjust our focus and turn our screen pot down. Ah, beautiful. Look at that. Crisp as you could even hope for. Okay, so we're upside down. So let's turn this off and let's flip the brown and gray, I think it is. I don't want to get this wrong. Hang on one second. Okay, yes, I'm correct. Brown and gray are vertical. So we'll just take this off and flip the gray and the brown. And that should flip us right side up. All right, so that being done, here we go. There we have it. This is my test tube, so it's old and tired. That's why I use it as a test tube. But do we have RGB? He hopes, he says, as he presses the button here. Yep. Well, look at that. Fantastic. I'm not going to go through adjusting colors and stuff here. We're just checking to make sure it works. And voila. How about our, well, not worried about convergence because this is the test tube, but our convergence is pretty good. So, well, there you have it. G07 resurrected. It's too wide. Can I grab the width tool here and let's go back to the main screen. And let's see if we can trim in this width here. Okay, this way. And I'm going the wrong direction here. No, I'm not. What in the world? All the way down is usually, it's moving. This is as far down as it goes. Is that stuck down in there? I mean, I don't know. Let's grab an actual board. I mean, it's centered. I wonder, I can't. Let's just grab a real PCB. Hang on, let me get a real PCB hooked up and see if we can make it look good with a real board. Okay, so I just reset the board, and this is about the best I could make it look with this tube being my test tube, and meaning that it's just tired and needs a bit of rejuvenation work. But yeah, the image, you have the 3-position jumper to have it centered, shifted right or shifted left. Right now I have it set on the position to shift left, and this is as far left as it's going to go. And I was able to shrink the image as narrow as it can go. And if we were able to shift the image over to where it needs to be, we would have a full screen. You can see it's the zeros are missing. The zero's missing here, and the 6 and the what is that? 14, the 4 and the 0 are missing because it needs to shift over a little bit more. If I was able to do that, I'd have a full screen. So width is pretty good, about where it can go to the maximum or limit anyway. And this is as good as the picture is going to look on this tube, and it's really not that bad. I need to do the horizontal centering mod that allows you to put a pot on there to center the horizontal position, and that's kind of the outside of the scope of this video. This was just to get this thing resurrected and up and working, and all that stuff I can do at a different time. So, but yeah, I mean, it's not too bad. This tube is weak and isn't that great, but for testing, yeah, it works fine. So you can see how it needs to shift over more. So the width is fine now. If I was able to shift this over where it needs to be, you'd have about, I don't know, 1/8 of an inch on here and 1/8 of an inch on there. So it'd be centered and be good and be perfect, but I just can't shift it over anymore because these G07s, you can't adjust that. But there is a mod that allows you to install some resistors and a pot and shift the image left and right. I think I have a video on that. I'll try and find it and link it down below. But for the purposes of this video, yeah, we are resurrected and good to go. We had the blown up flyback, the bad width coil, bad flyback. We had the missing R514. We had a bunch of bad caps. We had a bunch of bad solder joints. We had the cracked PCB in 2 spots. That's basically about it. All right, sorry about that, my phone rang. So as I was saying, this was a very interesting repair. I haven't seen a cracked one of these come along in a while. So that being said, I appreciate it. Again, as always, like, share, and subscribe. Stay tuned for more, and I appreciate it.